So I would like to talk about the overview of RECOMP project, which is a trilateral project consisting of Japan, France, and Germany. So the members of the primary members are me and Jean-Gabriel Ganascia, Gauvain Bourgne from Sorbonne University, and Adrian Paschke from Fraunhofer Research Institute. So today I would like to give this trilateral project called RECOMP, which is an abbreviation of a real-time compliance check project. And I give some examples. And if I have time, I would like to give some formal reasonings mechanism. So with the development and spread of AI techniques, ensuring the adherence of AI's behavior to legal and ethical principle has become a major subject. For example, automatic driving car, they should follow the traffic rules and so on. And the high-level expert group on AI set up by the European Commission recently published a report on ethic guidelines for trustworthy AI, says that AI systems should be lawful, complying with all applicable laws and regulations, and ethically ensuring adherence to ethical principles and values. Previously, I was involved in some project of the legal compliance mechanism, and for this kind of report, I'm thinking about involving ethical compliance as well. So we start this project. So the background is that this project aims at furthering this agenda by developing real-time legal and ethical compliance mechanisms. In this project, real-time means that checking and revision of agent behavior in real time, which will be embedded into the AI itself. So not only for the statistical compliance check, but also a dynamic compliance check when the agent performing some action. And we need a real-time mechanism since we cannot predict all the exceptions in advance because of the frame problem. So I think that for AI, the real-time compliance mechanism is inevitable. And our framework uses legal rules as hard constraints, which I must follow, and ethical rules as soft constraints, which should be satisfied as much as possible. And we apply to some kind of planning for the information, private information protection, like GDPR. And here is a general framework of the architecture, the behavior, a kind of system overview. And so the agent has current plan, and there is some new observation comes. Then if current plan cannot be executed according to the observation, then using causal theory, we have possible plan, which is physically permissible. And then we also consider about legal norms, and using legal compliance checker, we just filter out illegal plans. And we have legal plans, and then according to the ethical norms, we compare these legal plans, and we choose the plan which satisfies ethical rules as much as possible. And we also considering about some kind of strengths of ethical rules, so that the stronger ethical rules should be as much as should be satisfied as much as possible. And we have legal and ethical plan. Then the agent gives some actions, and then a new observation comes, and then the same thing happens. So this kind of loop is our system. Okay, so this is an example. So in the very simple data transferring problem. And a data carrier can physically move with data from a node to another node, which is connected. And we assume that we delete the data at the source node. And the owner of data D gives a consent of moving D from node N1 to node N2, so this is a kind of a legal constraint because without the consent, data carrier cannot legally move or move a data or a part of data from a place to another place without the above consent. And the data carrier also should not ethically move irrelevant data even with the consent of moving the data. And this is a specific, very simple example. There is a node, 4 nodes, I, A, B, Z, and I is connected to A and B, and A and B are connected to G. And data D1 and data D2 is stored at node I at the initial stage. And the goal is that the data D2 should be moved from I to G. And there is information about consent which says D1 can be moved from I to A, I to B, A to G, B to G. But D2 can only be moved from I to A, A to G. That means D2 cannot moved through node B. And also there is information that data D1 is relevant for this data move. And so firstly, we consider about some multiple physically plausible plans. So for example, in this case, we only consider about the connection between nodes for a physical constraint. So there are four plans. So together with D1 and D2, we move through node G or node B. And then only D2 is moved through node A or through node B. This is physically possible. However, according to the legal rules about the consent, only we can only move D2 through node A, so that plan 2 is no longer possible because it's illegal. And also plan 4 is also. Plan 4 is that D2 is only moved through B, but it's not legal. Then we can exclude non-classical plans if possible. So there are two possible legal plan 1 and plan 3. And then plan 1 moves irrelevant data because D1 is irrelevant. Therefore, plan 3, where D2 is moved only through node A to node G, is ethically legal and ethically compliant plan. So we can have that one. And however, we can violate ethical rules if necessary. Suppose that the D1, D2 cannot be physically separated and physically must move together. So in this case, plan 3 is impossible because D2 is separated. So in that case, plan 1 is selected, even though that that plan violates the ethical rule. So in this meaning, ethical rule is a soft constraint. And unfortunately, I didn't give a real-time example. So for example, if the D1, D2 is moved from node I to node A, and then something happens that some ethical rule is changed according to the context, or some legal rule is changed according to the context, then we should replan about the current plan from node A, not node I, because the D1 is already moved. And that kind of the examples we are now considering. Okay. And I just briefly explain about how to reason about this kind of thing using event calculus. So this is initiates and terminates, which represents the fluent is true at some action, or fluent becomes false after some action. And also we have reasoning about fluent's truth value, which is very standard in event calculus. So if there is the action which initiates f at time t1 and t is more than t1 and t is after t1 and there is no clipping event, then the as an by inertia f is remains true and so on. And also for the planning, we have abducing predicate, which is assuming of some plan at the time t. And gathering these abducibles, we can form the sequence of actions. And so this is a precondition of performing actions, and it expresses physical constraint that is source destination and holds that post data that source at time t. This is physical constraint, and the next two conditions are about consent, so which is legal rules. So together with these preconditions, move can be legally and physically plausible and legally compliant. And so the representation is like this: con AG, con IA, con BG, con IB for the connection and the initial condition. And also consent is like this kind of fact. And there is information that data D1 is relevant for this data. So to check the relevant data moving, we introduce movie relevant data, which is reason from abducibles and contains relevant data predicate. And if we have, for example, we can run this program in ASP solver, and if we have multiple ASP answer sets, then we check whether some solutions less containing irrelevant data predicates. Okay, and we set the goal holds that post data D2 G at time 2, and then we can have the following solution: perform move data D2 IA at time 0 and perform move data D2 from A to G at time 1. And so this is a plan which is the legal and ethically compliant. And if we change, if we add the integrity constraint D1 and D2 cannot be moved together, then the this solution doesn't come out, but as a solution which violates the irrelevant data move, and D1 and D2 are moving together. Okay, so this is a very brief introduction of our project. And legal plan is a plan which satisfies the legal rules as hard constraints. And the legal and ethical plan is a plan which satisfies ethical rules as soft constraints. And here we give a very simple formalization by event calculus. And the future work, we would like to have some kind of very fast event calculus reasoner with respect to ethical soft constraints. Okay, thank you very much. That's all.
Well, thanks, Ken. Thanks all for the talk, and thanks for accepting our invitation for the paper. And so we have time for one question. Any question? Paya, okay.
Hi, Ken.
Hello.
Thank you very much. It is a very nice talk. I was not very sure about what does it mean about the data moving in the context of ethics and the law. When we talk about data moving from one node to another, but it is in the context of legal and ethical context. I was thinking whether you can give an example, what a movement of data movement, what does it mean?
You know that in GDPR,
Mhm.
we need, if you would like to move private data from one place to another place, then you need a consent. That is a legal constraint.
That kind of data. Okay.
And also the ethical one is not, so in GDPR, if the owner of the data gives the consent, then anything can be done for that data. But ethically, I think that the necessary data should be sufficient and necessary data should be moved. And if there are some unnecessary data is moved, it's not ethically correct, because there are some possibility of being leaked, and if unnecessary data should not be leaked, for example. That kind of thing is exists in the ethical consideration in moving of personal data.
So by default, the data should not move, right?
That's right, yes.
So it is only when there is a necessary requirement, legal or ethical necessity.
That's
only
right. That's
the
right.
data should
But
be.
the ethical rule can be violated because it's not the hard constraints. But the legal rule, if you violate, you have to pay fine.
Yeah.
Like Google.
Yeah. So yeah, no, I got it. Okay, thank you very much for explaining that.
Okay. And
Maury, no question. Yeah.
Hey, Ken, it's great to see you. Just, you know, I wonder whether, I guess you've thought about this fact that you probably need to somehow automatically obtain these rules, right? You're not going to manually specify the rules. And I'm just wondering whether you might have some comments on how feasible it is at the moment, like to automatically obtain the rules in some way.
Well, actually, we are working on translating natural language rules into logical form. But for example, we use BART language model, but the translation rate is not so good.
Right.
I mean, for example, there is some work by Livio about the ontological translation from GDPR to some language, logical language, and we simulate that one by BART modeling, but currently F1 measure is 40%.
Wow, that's interesting. That's really interesting. Yeah, that's good.
But also, so GDPR is written, but ethical rules is more difficult because these are not explicitly written. Therefore, how do we obtain this kind of ethical rules from the literature is more challenging.
Yeah, yeah. Well, I mean, I think your comments are really interesting, even, you know, having had some students look at trying to do this sort of translation into other logical forms. I think this is a really interesting point.
Okay. And I think that Roland gives some question to me in the chat.
The chat is for Dennis and Christina, actually.
No, actually, it's as far as I understand, Ken, it looks like hard constraints or legal rules are like obligation in the modal logic terms concept, and we can relate to the notion of divisible rules for the ethical principle. Am I right? Yes.
Yeah, I think so. yeah, soft constraints are really diffusible rules. And we use hierarchical constraints instead of priority rules, priority over rules in diffusive logic.